Let's take a look at this. Let's see if we can actually see if we got this correct or not. All right. So the mass of the ball is 1.5 kilograms. Assume the boy moves the ball so slowly to the edge of the cliff that it has negligible kinetic energy and drops off the cliff with initial velocity of 0. So you know how like cats just like knock things off everything, right? So imagine like this thing was just nudged off, so it really didn't have kinetic energy from the beginning, okay? And let YA be 200, right? 200 meters. So here is my 200 meters, and YB is 160 meters, right? And YC happens to be 100 meters. Maybe I should get a different color. Okay. So let's think about calculating potential energy at point A. Okay. So here, since potential energy at point A is just mgy A, right? That is equal to 1.5 kilograms times 9.8 times 200, right? And if you do that correctly, okay, you should get positive, right, 2,940 joules. Okay. Well, what about at potential energy at point B? That's again mgyb, and that is 1.5 times 9.8, right, times 160, and that is, you get positive 2,352 joules. And then at point C, so that's mgyc, right? That is 1.5 times 9.8 times 100, and that is equal to positive 1470 joules. All right. So it says here for part B, calculate the change in gravitational potential energy from A to B. From A to B. So from A, which is here, which is the initial, right? And B, which is final, right? So what you really need to do is you need to do U final minus, right, minus U initial, right? So what is U final? U final is the UB, right? So UB is 2,350. I forgot the 2 here. Sorry. 52, right? Minus 2,940, right? So if we work that out, you're going to get negative, right, 588 joules. That means that's how much energy, potential energy, was lost, right, by going from here to here. It lost this much of energy, 588 joules of energy. All right. Next, change of potential energy from UB to UC. So UC is the final. UB is the initial. Right? So this is same as UC minus, right, UB. Right? Maybe I should write this as UB minus UA. Okay. So UC is 1470, right, minus 2352, right? So what is that? That is basically negative 882 joules. Again, that's how much energy was lost going from B to C. All right? Excuse me. All right. Let's take a look at part C. Assuming all of the potential energy lost and going from A to B was converted into kinetic energy, calculate the speed of the ball at position B. Okay? Well, we know potential energy was lost from here to here, and that amount of lost happens to be 588 joules. Well, that lost in potential energy is how much kinetic energy it gained. Okay? So when you gain this much energy in kinetic energy, right? So kinetic energy is positive, right? Positive 588 joules. Right? That kinetic energy has to be same as 1/2 mv squared at point B. Right? Maybe we should write that down. So we know the mass, right? So we can say, right, 588 is equal to 1/2 times 1.5 times V at B squared. So V at B squared is equal to, right, 588 times 2 over 1.5. All right, and that comes out to 784. So V at point B is square root of that, which is 28 meters per second. So that's how fast it is traveling at point B. All right. Part D, calculate the change in potential energy from A to C. Right? So they're just asking what is U from A to C, right? So, again, this is the initial right here, right? and this is the final. So that is same as saying, right? Maybe I should put the change. Right? That is saying UF, right? UC minus UA, right? Therefore, if we were to work it out, here UC, we have it as 1470 minus UA, which is 2940. So the change in potential energy is negative 1470 joules, right? Therefore, kinetic energy, right? Kinetic energy at A, right, is equal to positive 1470 joules. Okay? So obviously you can use this and this equation again to figure out how fast it's moving at point A. Okay? So I know we've selected that this to be 200 and this to be 100. But what if we made this 100 and this 0? Would the answers change? No, I don't think so, right? Because if you were to think about it, if this is 100, this would be 1470. And if it's 0 right here, then your potential energy is 0. So 1470, right? And then 0. So 0 minus 1470, you're still going to get negative 1470, just like here, we did it here, right? So the answers for the change in potential energy would not change, right? So, these answers would not change. Right? If YA is equal to 100 meters and YC is equal to 0 meters. Right? Because UC would be 0 joules and UA would be 1470. Therefore, change in U from A to C would still be negative 1470 joules. Okay? All right. Moving on. Let's take a look at the second page. Here, consider a 1 kilogram block attached to a spring with a spring constant of 200 newtons per meter. The block is pulled to position XA, which is positive 0.75 meters, and released from rest. Now, since it's released from rest, kinetic energy at point A is 0. Okay? Only energy it possesses here at this point is just potential energy of the spring. Assume no friction or other energy loss in the system. So since this is frictionless, there's no work done by non-conservative force. Okay? So assume all potential energy lost will result in kinetic energy gain and vice versa. All right? So here at this location, this is equal to positive 0.75 meters. Okay? So that is location at point A. So U, potential energy at point A, is simply nothing more than just 1/2 K XA squared, right? That's all it is, really. So if you just plug and chug, you get 1/2 times 200, right? Times 0.75 squared. And that is equal to 56.25 joules. Okay? What is the kinetic energy at point A? Well, kinetic energy at point A is 0, right? So 1/2 mva squared. And since velocity or speed at A is 0, right? 0 joules, right? What about at U of 0 right here, at the origin? Well, that is simply 1/2 kx naught squared, and that is 1/2 times 200 times 0 squared, therefore 0 joules. Where did it all go? From here to here. Well, all the potential energy at point A converted into kinetic energy at 0. Okay? So, kinetic energy at 0 here would be positive 56.25 joules. As you could see, because this is positive, this would be squared, so it would be always positive. So potential energy of spring will always be positive. Kinetic energy will always be positive, right? Positive, positive. Now, if you take a look at this, change in potential energy from A to 0. Now, that's a different story, because change in potential energy here would be U0, right, minus UA, right? Therefore, U0 would be 0 minus, right, 56.25. Therefore, change in potential energy would be negative, right, 56.25 joules. Again, because change in potential energy is negative, your kinetic energy becomes positive. Okay? So, how fast is that block moving? Right? Well, we know the kinetic energy is 56 right? So kinetic energy at point 0 is 56.25, and that is equal to 1/2 times the mass is just 1 kilograms, right? Times v squared. Right? So if you work it out, right, v squared is equal to 2 times 56.25. So v is equal to 10.6 meters per second. All right. All right. So let's take a look at B. Let X at B represent the maximum position of compression for the spring. The block will momentarily come to stop at this point. So using the kinetic energy at x equals 0, what value would you expect for potential energy at position xb will be? Right? What value for xb would you expect? Well, you know, there's no other energy being lost. And if it has this much potential kinetic energy at 0, that kinetic energy has to convert into potential energy of the spring until it loses all the kinetic energy at this moment. Well, at that moment, since I have no kinetic energy, it must have all converted back into potential energy of the spring. All right? So, since kinetic energy at x equals 0 is 56.25 joules, right? If all of the kinetic energy is converted into potential energy of the spring, right? Then we expect, right, U at xb, right, equal 56.25 joules. And xb must equal to negative 0.75 meters. All right. And then last but not least, if the block has been given an initial velocity and flick to the left of 6 meters per second when it was set into motion at this, right? Then A, how would this have changed the kinetic energy answer that you have gotten in part A? And how would this have affected the value of xb in part B? Well, once you have the kinetic energy here, that means not only you have potential energy, but you also have potential energy plus the kinetic energy at this point. That means it's going to probably come here and it would still have that same potential energy that we started here, but it also should have the same amount of kinetic energy it started with. Okay, so it should be going further in and compress even further in, right, due to that. So hopefully, if, right, kinetic energy initial at x a equal to 0.75 has, right, as 1/2, right, 1 times 6 squared, which is 18 joules. Then, right, the total kinetic energy, or the total, right, kinetic energy at, right, x equals 0 would Then, right? 56.25 plus 18, which is 74.25 joules, right? And U at XB would be 74, right, 0.25, right? That is equal to, right, 1/2 200 times XB. Therefore, XB is equal to negative 0.86 meters. All right. And that's the way it is. Wow, we hit it right on the nose. All right, we'll stop there. I'll see you Friday.